Hello everyone. This is still in connection with the understanding of a midpoint. As we discussed in the module, midpoints are also considered to be the bisector of a segment. Bisector means it divides a segment into two equal parts, or we divide a segment into two different segments with the same measurement. So let us try to consider this in our problem. Still, points L, M, N are collinear. Okay? And we have here point M is the midpoint of line segment LN. Since point M is the midpoint of line segment LN, we could assume that whatever will be the measurement of line segment LM is equal to the measurement of the line segment MN. At, as this is what the midpoint between points theorem tells us, that if point M is between or midpoint, the midpoint of line segment LN, it tells us that the measurement of line segment LM must be equal to the measurement of line segment MN. This is what we're going to follow. We need to substitute only the values. So LM is 2x and MN is x plus 10. Again, this only happens because of the assumption that point M is the midpoint of line segment LN. And just need to solve for x, though it's not asked here. We simply need to solve for x to determine the measurements of the line segments here. And to do that, you have 2x, subtract x both sides. So we could actually come up with an equation wherein the variable is on the left hand side. 2x minus x, again, what you did here, let's do it on the other side. 2x minus x is x, and the other side, the variable will no longer be there. The answer is 10. So the value for x is actually just equal to 10. With this value, let's try to solve for the measurement of LM and the measurement of MN, and later on the measurement of LN. And we are going to determine if the value here is actually really correct or not. But first, again, let's solve for LM. The measurement of line segment LM is given to us by 2x, and x is 10. So that's 2 times 10, which is actually equal to 20. This is the measurement of line segment LM. As for line segment MN, right, you have here x plus 10, and x is 10 plus 10. Line segment MN, its measurement, again, this is measurement, is equal to 10 plus 10, which is actually 20. Before we solve for the measurement of the longest line segment, let us try to see if the results will satisfy this equation following the value for x. Again, this equation here is taken from the midpoint between points theorem. So let's try to determine if LM is really equal to MN. Is LM equal to MN? You have 20 equal to 20. This is also already checking. It satisfies the equation. That would mean that the values for length of LM and MN together with the value of x which was used to solve for both are correct, and they are acceptable. Since we are now sure that these three uh, variables, or I mean unknowns, are already correct, we can now solve for ln. And how is that? We could actually use here the segment addition postulate, which tells us that if the points are collinear, the sum of the smaller line segments must be equal to the length of the longest line segment. Let's check. LM is 20 and then MN is 20. This should be the measurement of LN. 20 plus 20, 40 is equal to LN. By symmetric property, LN is equal to 40. With this is actually now the value of the measurement of line segment LN. And if you're going to divide this into two equal parts, as for the midpoint is concerned, you will get 20 and 20 for both line segments. This is the additional problem. It's still concerned with midpoints, but not with the coordinates anymore of L, M, and N, but with the measurement of the lengths given to be variables or unknowns. Please use this final video, for our first long quiz scheduled soon. See you in the next upcoming videos. Goodbye.